energy transfer. We are going to discuss the conceptual meaning of the work-energy theorem and how kinetic energy gets transferred from object to object and transformed into other kinds of energy. Look at these two scenarios here and these two descriptions of those scenarios. I'm going to ask you to write a corresponding description for this third scenario in a moment. First scenario, as this gem gets tossed from moment 1 to 2, assume it's in the air that whole time, so it's in free fall that whole time. The net force on it is just the force of gravity. If that angle between net force and displacement is greater than 90 degrees, then we know the work done by gravity between moments 1 and 2 is going to be negative according to our formula number 1 for work, based on cosine of an obtuse angle being a negative number. So the net work, which is just the work done by gravity, since gravity is the only force acting between those moments. Since the net work is therefore negative, that means the change in kinetic energy between those two moments is negative. So the kinetic energy decreased from moment 1 to 2. Actually, it decreased from 1 to up here, but then it increased again from up here to 2. So the net change over that time interval is a net decrease. That's what the work energy theorem is telling us. Kinetic energy at moment 2 is going to be less than the kinetic energy at moment 1 because the net work was negative during that time. So we say that the force of gravity removed kinetic energy from the gem over that interval. So final kinetic energy being less than initial kinetic energy means that our final speed is less than the initial speed, since kinetic energy is 1/2 mv squared. So all that is to say that our object is slower at moment 2 than at moment 1. Second scenario, here's our moment 1 and our moment 2. Since the angle between displacement and net force is 90 degrees here, the work done by gravity between those two moments is 0. Cosine of 90 degrees is 0. So the net work, being the sum of all the works, well, there's only one work being done, only one force doing work, gravity. So the net work is the work done by gravity is also 0. So the change in kinetic energy is 0. Now, that doesn't mean the kinetic energy is 0 at 1 or 2. It means the change is 0. And so it is the same kinetic energy at 1 and at 2. So the force of gravity, here's our interpretation. The force of gravity, it would have removed kinetic energy on the way up, but then added back the same amount of kinetic energy on the way down. So K final equals K initial, and our final speed equals our initial speed from moment 1 to moment 2. Here's the third scenario. I want you to pause the video in a moment and write down a corresponding sequence of statements that describe the conceptual logic behind all of these work energy concepts for this scenario from this moment 1 to this moment 2. Write down those statements. Pause the video now. Ready? You should have written this. If the angle between net force and displacement is less than 90 degrees, then the work done by gravity, according to this formula, is going to be positive, since cosine of an acute angle is a positive number. Therefore, the net work, which is equal to the work done by gravity, which according to the work energy theorem equals the change in kinetic energy, is positive. So the force of gravity added kinetic energy over that interval, so the final kinetic energy is greater than the initial kinetic energy. The final speed is therefore greater than the initial speed. Gravity added kinetic energy, speeding the object up between moments 1 and 2. All right. The essential point is this: work done by a force does not create or destroy energy. Work only transfers existing energy from one object to another, or transforms existing energy from one type to another. So this character is one of our hardworking dwarf miners who's going to be helping us understand these transfers and transformations of energy via the concept of work. So some illustrations of energy transfer and energy transformation. Let's look at the part of the story before the gem was in free fall, the part where the miner is pushing upwards on the gem from this moment 1 to 2, pushing it straight up, throwing it. Moment 2 can be the moment just as the gem is losing contact with the miner's hand here. So the free body diagram for the gem between moments 1 and 2, as it's being pushed upwards, would include a very large upward applied force from the hand and the force of gravity downwards on the gem. There's a little displacement vector between moments 1 and 2. These orbs represent different types of energy. A blue orb represents some kinetic energy. A green orb is going to represent some gravitational potential energy. A cyan orb is going to represent some chemical potential energy. And this little icon here, this pixelated dwarf face icon, is going to represent a force. I've drawn a red harpoon over the icon there to help remind us that this is a force vector. That harpoon is going to do double duty, serving also as our dwarf's shovel here, by which he does the work transferring energy from one place to another or from one type to another. So let me explain what I mean by this little diagram here. This represents a certain moment in time, moment 1, say not long after the dwarf begins to push upward on the gem. So this free body diagram applies. The applied force here is going to be doing positive work. We see it's in the direction of our displacement, 0-degree angle between them. Our force of gravity is going to be doing negative work. We see it's a 180-degree angle between gravity and displacement. So these two bins, the one marked miner and the one marked gem, represent the some of the energy held by the miner and some of the energy held by the gem. This icon with a subscript A, this is a force. Each little dwarf face icon is a force, with the subscript telling us what kind of force. This is the applied force here. And this icon represents the force of gravity. So what our applied force is doing between these two moments is taking chemical potential energy that's in the miner's muscles, which the miner got from the breakfast of biscuits and gravy he ate this morning, take that chemical potential energy and via work, transfer that chemical potential energy to the gem, adding it as kinetic energy to the gem, speeding the gem up. So with the miner's little shovel here, he's shoveling these cyan orbs from the miner over to the gem, adding them as blue kinetic energy orbs to the gem. That's the positive work being done, adding kinetic energy by the applied force during this time. But at the same time, the force of gravity is doing negative work. It's removing kinetic energy. So here's our force of gravity with his little shovel, scooping up kinetic energy orbs as they arrive and transferring them via work over into a third type of energy, gravitational potential energy. That's what the force of gravity does. It takes kinetic energy and turns it into gravitational potential energy as an object moves upwards. The higher the object is, the more gravitational potential energy it has. So we see the object actually started out with a little bit of gravitational potential energy because it started out already above the ground. It had some height at the beginning, so it already had some gravitational potential energy at the beginning. And as the object moves from 1 to 2, it's gaining more and more gravitational potential energy. Our story continues to the moment when the gem loses contact with the miner's hand, becomes airborne, so our applied force disappears. But let's assume that at this time a wind begins to blow, and so this drag force from the wind appears. It'll be a constant drag force to the right. So we're going to follow this story into the future. So our wind arriving is indicated by this bin here showing up containing a bunch of kinetic energy. The motion of the wind means the wind itself, which has mass and is moving and therefore has kinetic energy. The wind's kinetic energy gets added to the scenario. So by this point, the miner's chemical potential energy in his muscles has all been transformed into kinetic energy here via the work done by the applied force. The force of gravity has already taken some of that some of that kinetic energy and transformed it into gravitational potential energy via the work done by gravity. But count up the orbs in our scenario here. We started out with 1, 2, 3, 4, 5 units of energy total. And after the applied force does some work to transfer chemical potential into kinetic, and after gravity does some work transferring kinetic into gravitational potential, we still have 5 total orbs here. We have not created or destroyed any energy in these work processes. We've only transferred energy and transformed energy, not created or destroyed. Once the wind arrives on the scene, the wind does bring a bunch of new energy with it. And so now the applied force leaves the scene, but the drag force shows up. And the drag force from the wind is going to start doing work on the gem. The wind is pushing the gem to the right, and its force is going to be transferring the wind's kinetic energy over to the gem. The wind is going to slow down as it crashes into the gem, but the gem is going to be sped up by that push it gets from the wind. That's a transfer of kinetic energy from the wind over to the gem. Meanwhile, the gem is still moving upwards from moment 2 to 3. So we are around moment 3 now. So as the gem moves upwards, gravity is still doing negative work. See that obtuse angle between gravity and velocity? So the negative work by gravity means gravity is removing kinetic energy. But when gravity removes it, it doesn't destroy it, it transforms it into gravitational potential energy, turning blue orbs into green orbs here via the work done by gravity. Let's look ahead. Beyond the apex of the gem's path, it's going to be now moving downwards, still being pushed to the right by the drag force, still being pulled downwards by a constant force of gravity. So around moment 4, let's look at what's happened. By this time, much of the wind's kinetic energy that it brought to the scene has been transferred over to the gem. The work done by the drag force has moved kinetic energy from the wind to the gem, but also once the object hit its high point and began moving downwards, the angle between gravity and velocity became acute, meaning that gravity started doing positive work. Gravity stopped removing kinetic energy, putting it into the potential form, and started adding kinetic energy, taking gravitational potential and shifting it via work back into the energy pile, back into the kinetic energy pile right here. So for moments 3 to 4, we've got both the drag force from wind and the force of gravity doing positive work. They're both adding energy into the gem's kinetic energy pile, speeding the gem up from moments 3 to 4. And if we count the total number of orbs here in our story, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 total orbs here. That is the 5 we started with, plus the 6 brought in by wind. So 11 total units of energy here at the end. No energy has been created or destroyed throughout this story. It's just been transferred and transformed by these work processes.